Our last example is going to look at a disk that has a charge distribution evenly distributed, and we want to find the potential at point P due to this disk. So the differential area is going to be a concentric circle in this disk. Now the question is, how do we find our differential charge? Well, always do ratios, part over the whole. So our differential charge over all of the charge in the disk is going to equal, well, for our differential area, we need 2 pi r, that's the circumference, and then we have to do a little bit more dr, and r is this distance here, and our whole area is pi r naught squared, and r naught is from the center out to the edge. The pi's are going to cancel out, and I can bring Q up to the other side, so my differential charge is equal to two Q R dr over r naught squared. So we have our potential function, and that's going to be equal to 1 over 4 pi epsilon naught, and just bringing that out of the integral. My integral is going to be evaluated from 0 to r naught dq over little r. Little r is just from this edge to our point P, and that's just equal to, we have x there, square root x squared plus r squared. Now I can substitute, and my dq is 2q r dr over r naught squared. 2 and the q and the r naught squared are constants, and I forgot my little r down here, and little r, I'm going to put that in, is the square root of x squared plus big R squared, which means I can't take it out of the integral, but I can take a few things out. The 2 is going to cancel part of the 4, so I'm going to have q over 2 pi epsilon naught r naught squared times the integral from 0 to r naught of r dr over the square root of x squared plus r squared. So I need to evaluate this integral. I can use the integration table for that. And the integral that I'm interested in is here, where I have x divided by the square root of x squared plus or minus a squared dx, and that's just the square root of x squared plus or minus a squared. And if I put my limits in, I get q over 2 pi epsilon naught r naught squared times the quantity square root x squared plus r naught squared minus, now if I put 0 in for r, that just leaves me with square root of x squared, so I'm going to have a minus x. And that's the potential due to this disk with the charge distributed evenly across it. And this is the potential at point P.